A program does nothing unless its instructions are executed by a CPU. A program in execution is a process. A time-shared user program, such as compiler, is a process. A word processing program being run by an individual user on a PC is a process. A system task, such as sending output to a printer, can also be a process. For now, you can consider a process to be a job or time-shared program, but later you will learn that the concept is more general. A process needs certain resources, including CPU time, memory, files, and I/O devices, to accomplish its task. These resources are either given to the process when it is created or allocated to it while it is running. In addition to the various physical and logical resources that a process obtains when it is created, various initialization data may be passed along. For example, consider a process whose function is to display the status of a file on the screen of a terminal. The process will be given the name of the file as an input and will execute the appropriate instructions and the system calls to obtain and display the desired information on the terminal. When the process terminates, the operating system will reclaim any reusable resources. We emphasize that a program by itself is not a process. A program is a passive entity, like the contents of a file stored on the disk, whereas a process is an active entity. A single-threaded process has one program counter specifying the next instructions to execute. The execution of such a process must be sequential. The CPU executes one instruction of the process after another until the process completes. Further, at any time, one instruction at most is executed on behalf of the process. Thus, although two processes may be associated with the same program, they are nowadays considered two separate execution sequences. A multi-threaded process has multiple program counters, each pointing to the next instruction to execute for a given thread. A process is the unit of work in a system. A system consists of a collection of processes, some of which are operating system processes, and the rest of which are user processes. All these processes can potentially execute concurrently by multiplexing on a single CPU. The operating system is responsible for the following in concern with process management: sharding processes and the threads on the CPUs, creating and deleting both user and system processes, suspending and resuming processes, providing mechanisms for process synchronization, providing mechanisms for process communication.